This demo shows how an application developer will use Yocto plugin features within Eclipse IDE. This is a fresh installed Eclipse IDE with Yocto plugin installed. First, we need to configure the Yocto plugin for toolchain location, target architecture, and target type, QEMU or real hardware. I'll bring up the configuration window. For cross-compiler options, there are two choices, SDK root mode and Pocket Tree mode. SDK root mode means you want to use cross toolchains that installed with Pocket built SDK tarball. For SDK root mode, the Pocket root location will always be opt-Pocket. Pocket tree mode means you want to use the toolchain that bundle inside Pocket build tree. For this mode, you need to specify the Pocket root location based on your system setup. For this demo, I'm going to use Pocket tree mode, so I need to select my Pocket root location. Once the Pocket root location is selected, a supported target architecture list will be built based on your Pocket root location setup. You need to select the desired architecture from the list. Next, we need to specify what target we want to run against. There are two options, QEMU and real hardware. For demo, I'll be using QEMU. I'll select the QEMU kernel first. The IDE will boot QEMU through user mode NFS. You need to specify QEMU root file system mount directory. Make sure we make the right selection. Now, Yocto plugin is configured. Please note this setup will be used as default setup across IDE. Next, we'll create an AutoTool-based Hello World project from Yocto project template. We just fill the wizard here. Since it's a C project, IDE will prompt us to switch to C++ perspective. We just say yes. So the contents is filled by the templates. By going to Projects, invoke Yocto Tools, reconfigure Yocto. It will bring up the project-specific Yocto setting dialog. And here, you can change the settings specific to your project. We can see these values are inherited from Yocto config we just did. For the demo, we don't want to change anything. Since this is an Auto2-based project, I'll run autoconfig. Let's bring up the console so we can see. You can see it's setting configured to use the Cross toolchain. Now let's build the project. Please note the Cross compiler is used. Now I'll bring up QEMU through IDE. We can see QEMU is coming up. Let's bring up a terminal to note down QEMU IP address. Next, I'm going to deploy and debug my Hello World application to QEMU target. And bring up my project's debug configuration. By default, the application will be deployed to the target first. The remote absolute path is where on the remote target I want to deploy my application. I also want to point out it is using the Cross GDB for debugging. Next, I need to create a new connection to the QEMU instance. We'll need to select TCF. TCF means Target Communication Framework. Yocto Projects plugin has done lots of extension work here. Hostname, I specify my QEMU's IP address. This is the TCF connection settings. I'll use the default. So I choose the new connection. It will prompt you to log in to the remote site. And prompts you to switch to the debug perspective. This is the debug view, and by default, it breaks at the main. I'm stepping through my debug session, and switch back to C++ perspective. In console, we can see the remote execution are redirected here. Let's bring up QEMU to validate the deploy. Yes, the program is deployed at the right location. Let's execute it. Hello world. Next, I'll be switching to Remote System Explorer RSE. Here, my local files and remote system files are shown in the tree view. We can do file manipulations like copy, rename, delete, etc. So I'm copying one UST instrumented test programs to the destination. Oh, it's already there. Let's override it. I'll bring up QEMU to compile the newly transferred file. Oops, wrong location. Okay, the file's compiled. Last, I'm going to demo some Yocto image provided user space tools on the remote target through the plugin Remote Tools feature. This is our Yocto tool suite. First, let's run PowerTop. We can see PowerTop is up running. Then let's run latency top. The latency top is running in the remote terminal. Last, I'll run LTTNG user space. I'll specify the copied over UST instrumented test program. The tracing data will be collected on the remote target and transferred over to the host side and brought up view in the LTT viewer on the host. It worth to point out all the remote target interaction and services are facilitated through remote TCF agent that is part of Yocto plugin deliveries.